Hi there and welcome back. In this final video on sections 10.1, 10.2, and 10.4, we'll look at some worked examples of hypothesis tests that will hopefully give you an idea of how these things work in all of the contexts. Before we dive into that, I do want to touch on how we know we have to do a hypothesis test. So when you get to take your exam and final, everything is going to be mixed up and it's going to be very easy to get yourself overwhelmed and confused given all the content that we have covered so far. So what are the clues that tell us that we have to do a hypothesis test? Well, what you're going to look for are some of these key phrases. So the one is test the claim. This is a good indication that we have to do a hypothesis test. Another is if they ask us if we can conclude something. If they provide us with a level of alpha, that's also a very important giveaway because we need alpha. And of course, if they ask us, do we have enough evidence to do something? So if you see one of these phrases in combination with the alpha level, it's a good indication we have to do a hypothesis test. Now, with that out of the way, there's one more challenge to this because once we know we have to do a hypothesis test, the question is what kind do we have to do? In our instances, we've had two cases we've examined so far. One deals with means, and the other deals with proportions. Now we have more. We're going to add three more different types of hypothesis tests to our arsenal, and you have to be able to tell the difference. So right now we're kind of in the early stages. So how do you know you're dealing with a mean? Well, what you look for are the words average and the word mean. That's a good indication. For proportions, we look more explicitly for percentages, decimals that are between 0 and 1, wording such as blank out of blank, and certainly the word proportion. Okay, these are good indications. So make sure you get in the habit of determining number one, do we have a hypothesis test? And number two, which case is it? Is it means? Is it proportions? And then how do you know? So in this example, what I'd like for you to do is number one, decide if you have a hypothesis test. Secondly, determine if it's means or proportions. And number three, try to write a hypothesis, and we'll take it from there. So go ahead and pause the video and try those three things. Okay, hopefully you've had an opportunity to read through this. So what you should notice is that this is a hypothesis test because they ask us if we can conclude something. And you'll also notice they've given us a level of alpha. Second, this is dealing with proportions because we're dealing with percentages here. Additionally, I don't see the word average or mean anywhere in the context of this problem. So these are the fully worked steps that we're looking at. So I'll walk you through this. So the alternative hypothesis here is P is greater than 0.35, and that's because they think more students applied elsewhere. So that's why the alternative is greater. Now, if you look at step two, notice that the inequality matches the alternative hypothesis. So P is greater than 0.35, and then the probability that P hat is greater than 0.375. Those have to match. Very, very important. If the alternative was less than, then the computation in step two would be less than. Okay. It's very obvious that the null hypothesis is equal to 0.35. We've talked about that in a number of instances. In the computation for the test statistic, the 0.375 is coming from the sample. That's the 853 out of the 2,275. Okay, very important we obtain that. And you'll notice the computation, we're actually using formula number 34. So make sure you have your formula sheet to reference. If you need to pause and get it, go right ahead. But we are using formula number 34 for the computation. P hat minus P in the numerator divided by the square root using P times 1 minus P divided by N. So that computation comes out to 2.5, and that 2.5 is our test statistic. We look up the p-value. Okay, to do this, we go to our normal table. You'll notice that Z is greater than. This means area to the right. Okay, so you have two ways of dealing with this. You can look up negative 2.5, or you can look up 2.5 and subtract from 1. Either way, you get 0.0062. In step four, you take the p-value and you have to compare it to alpha. And so what you should notice is 0.0062, that's less than 0.05. So in that particular instance, we reject the null hypothesis. We're happy. We are excited. It's significant because that p-value is less than alpha. It's significant. So the conclusion here is at the alpha is 0.05 level of significance, there is evidence to suggest that more students applied elsewhere. Okay, that's important. So you'll notice the conclusion always has this structure: at the alpha is equal 0.05 level of significance, there is or there isn't enough evidence. In this case, there is, because we rejected the null and we put in what the context is. And this context is that more students applied elsewhere. Here's example 2. What I would encourage you to do now is try this one on your own all the way through. So decide whether or not it's a hypothesis test, work through the hypotheses, and come up with all of the steps. So go ahead and pause the video and give that a shot. Okay, hopefully you've taken an opportunity to work this one all the way through. So this is a hypothesis test because we are given a level of alpha here, okay, of 0.05. We know it's dealing with proportions, because it says the word proportion, as well as giving us things, excuse me, in terms of percentages here, 15%. So that's what we're looking at here in this context. Now, the challenging part to this one was actually forming the alternative hypothesis. So you'll notice that I wrote that its p is less than 0.15. And the reason it's less is because it's the hope of this instructor that the intervention, the algebra help, is going to reduce the attrition rate. That's what we want to do. We want to reduce it. That's why it's less than 0.15. You'll notice that in the computation of the test statistic, that inequality, that less than, matches the alternative. Okay, those have to match. Very, very important. The p hat, 10%, 10 over 100, that's coming from the sample. This instructor had 10 students out of the 100 who ended up dropping out. We again use formula number 34 from the formula sheet, and we end up with a test statistic of negative 1.39. In step 3 for the p-value, this is really easy. It's area to the left. We just simply look it up on the table. We get 0.0823. In step 4, you compare the two, and what you should notice is that our p-value, it's more than alpha, so it is not significant. As a result, we fail to reject the null hypothesis. There is not enough evidence. It's very, very sorry. So the conclusion here is at the alpha is equal to 0.05 level of significance, there is not enough evidence to suggest that more students need algebra tutoring. So again, notice the structure here. We always state the level of significance. We always state whether there is or isn't enough evidence, and then we put it in the context of the problem. Very important for my students. You guys have all three of those components in the conclusion. Here's the third example, which inadvertently also has the solution to it as well. So sorry about that. So you can go ahead and give this one a read, but we may as well just work this one all the way through. So if you want to pause and read the problem, that's fine. So in this particular instance, we are dealing with means because it says the mean cholesterol level. Okay. And we think that the cholesterol level is higher for the children compared to the national average. So that's why the alternative here is greater than. Mu is greater than 190. You'll notice in the test statistic that inequality matches, but now we're using X bar. So remember, we changed contexts here. Okay. Similarly, in the context of the computation, we're using a new formula. We're using formula number 33, which is the test statistic for the population mean. All right. And we work the computation out and we get 2.67. Okay, so this is a right-tailed test, okay, area to the right, so we know how to deal with this. We've done it before. There was another example that we looked at. The p-value we end up with is 0.0038. We compare this to the level of alpha, and what you should notice is that it's less than alpha. So as a result, we get to reject the null. It is significant enough. So the conclusion here is that at the alpha is 0.05 level of significance, there is enough evidence to suggest that only children have a higher cholesterol level than the national average. Here's example 4. Take a second, read this one through, and see if you can put the hypotheses together, as well as maybe work through some of the other steps. Okay, hopefully you've had a good opportunity to take a look at this problem. So we know this is a hypothesis test. They're asking us, can we conclude? We see that we have a level of alpha. Okay. And the context here is again the average because it says the mean temperature. So that's a good indication here. Now, the question is, which hypothesis is it for the alternative? If you look at the last sentence, it says, can we conclude that the temperature has changed since industrialization? They don't say how it's changed. They don't say if it's more or it's less. So because they leave that up to us, this is a two-sided test. So we say that mu is not equal to 50. So this is the first two-sided test that we have. So again, why is it two-sided? Well, I don't know how the temperature has changed. Could be more, could be less. They're not specific. Okay. Now, how do we handle that in terms of computing the test statistic? Well, since it's two-tailed, what you're going to picture is that it's area in both tails, left and the right. Because the normal distribution is symmetrical, we multiply by 2. Okay. And in fact, we take the easier of the cases, which is the area that's to the left. So if we look up the area to the left, there's no extra thought on the chart. We can just look it up right away. So that's why we take the probability here to be less than the sample statistic. So in this case, the sample mean. So two-tailed, you multiply by 2, and you take the area to the left. So you make sure the inequality is less than. So we use formula number 33 in the computation, okay, for the population mean, just like in the previous problem. And we end up with a test statistic of negative 2.22. To get the p-value, we look up the area to the left of negative 2.22, and we multiply that by 2. Very important, you don't multiply the test statistic. You don't multiply the z-score by 2. You only multiply the area, the probability you find in step 3. So when you do that, you get 0.0264. We compare that to alpha, and you notice it's less than 0.05, so we reject the null. So the conclusion is at the alpha is 0.05 level of significance, there is enough evidence to suggest that the temperature has changed since industrialization. Example 5. Give this one a shot. Pause the video, see what you make of it. Okay, hopefully you've had an opportunity to look at this one. This is a hypothesis test because it says, can we conclude? Gives us an alpha value, deals with alpha. And you know what? It's also a two-sided test because in the very last sentence it says we think the temperature is not 98.6. So this again is a two-sided test. So it's modeled almost identically after the previous example, just with different numbers. Okay, so still 2 times the probability. We're still using formula number 33. Our test statistic after you do the computation is negative 2.86. We look this up on the chart, multiply by 2. You get the 0.0042. You compare that to the alpha level of 0.05. You notice it's significant, it's less, so we reject the null. And our conclusion then is at the alpha is 0.05 level of significance, there is enough evidence to suggest that the average temperature of adult humans is not 98.6 degrees Fahrenheit. And then we have a final example, example 6. Give this one a shot, pause the video, see what you make of it. Okay, in this particular example, we're given the statement, do we have sufficient evidence? And we're given an alpha level. So that's how I know it's a hypothesis test. Second, I know that this is dealing with proportions because I see the word percent. I see percent. I don't see the word average or mean anywhere. So I know I'm dealing with proportions. Now, in this particular instance, we think that there are more than 10% of the elm trees infested. So this is going to be alpha, excuse me, the alternative is P is greater than 0.1. Okay. And you'll notice again that the test statistic matches that inequality. We compute the P hat, the sample that they took. 180 of those trees out of 1,500 gives us 12% or 0.12. We use formula number 34. We end up with 2.5 as the test statistic. This again is area to the right. We know how to handle that. Okay, you got 2 choices for how to do that. Either way, you get 0.0062 as your p-value, as your probability for this sample. So the question is it rare enough? Okay, is this sample rare enough? Well, we have to compare to alpha, and what do you notice? It is. It's less than alpha. It's less than 0.05. So this is significant. So we reject the null. So at the alpha's 0.05 level of significance, there is enough evidence to suggest that the infestation of the emerald ash borer is more widespread. So this concludes this video on hypothesis tests. So I hope you've had a good feel for how these sort of work. There is a structure that all of them follow. It's just a matter of which formulas do we use, etc. Make sure you pay attention to the type of hypothesis you have in the alternative, and you're watching your computations very carefully.